So I wanted to do an example of object-oriented programming and show you a little bit about how that works. And it's really hard to come up with a problem that is not completely trivial, but that's small enough to handle in the time we have. So this problem is still very much an invented problem, but hopefully it can illustrate a few things about object-oriented programming. So the first thing we have to do is define a class, and the example I'm using is a door class. And these parentheses can be left off if they're empty. I'm going to put them there just for didactic purposes, and we'll discuss what they're for in just a couple of minutes. And if we think about what characterizes a door, well, usually you can open a door. So I'm going to create an open method, and you can close a door. And typically then you would like to be able to know if the door is open or closed. So we'll simulate our actions with just print statements, okay? And we'll set a state variable. We'll call this open equals true. Self.open. Let's forget that. That makes it a property of the door object. And so this one would be print the door closes self.open equals false. Now, you might ask me about this underscore here. Anything that starts with one or two underscores is private to the class. So that means that although up here let's create a door. So door equals door. Now, again, empty parentheses, these are not the same as these parentheses. Don't confuse the two. This one means we're calling the class as a function, which causes it to create an instance of that class. These two have to do with inheritance that we'll get to in a minute. So I can call door.open and I can call door.close because they don't have these underscores. But if I try to, so first off, let's show that. Come on, reading. Okay, door opens, the door closes. But if I try to access that, even though there is an underscore open, it's going to report. Why did it not report that? That should have given me an error, and it didn't. I hate it when that happens. It definitely should not allow me to set that. Oh. What have I done wrong? I didn't think it had to be two underscores, but let's see if it does. See, there's no way that I should be able to reach into the door and just set its state to true or false. Well, all right. Even though it allows it, that's bad programming practice. We'll ignore that for the moment. I had thought, well, I've done this before with other classes, and I don't know why it's not behaving the way I expect right now. So we'll ignore that for a moment. Oh, no. it may be because, okay, let's try this. So when this door is created, what state is it? Is it open or closed? Well, we haven't defined. And so usually you define an init method, which is where you set up the object. And typically this is where you'll define internal state. And so we could say self._open equals false, so that our door always starts off closed. But really, I shouldn't be manipulating this variable directly. I should let the method do it. And so that's how I should set it up. I should call self.close that way. And now if we run this, we'll see the door closes when it's created. I make sure it's shut. Then I can open it and then I can close it. Does that change the behavior of that? No, it doesn't. I really don't understand why that's allowing that. Okay. In any event, when you see underscores on something, it means you're not supposed to use it from outside of the class. You should only use it from within the class. All right. Well, that was pretty exciting, but one of the characteristics of a door, if I ask you about a specific door, it's how does it open? Let's talk about the front door on my house, okay? So class front door. Now we get to these parentheses. Front door is a type of door, but it has additional characteristics that generically a door opens and closes. A front door opens and closes in a very specific way. Now, we might think of defining an open here. Let's say print the door opens by swinging on its hinges. And then we say self.open equals true. But, well, that, I've already got an open method. And it turns out the front door will inherit the open method. Let's show you. So I'm going to make my door a front door now. And I'm going to take out the open method here. So for the moment, this is an empty class. I just put pass in there. And even though it's a different kind of door now, I still can just tell it to open and close. And we'll see that it does still show the same behavior. So when I called open and close on front door, it said front door doesn't have an open and close, but if I look at door, it has an open and close. The only thing that's different is how it opens and closes. And so now we're going to change a little bit of behavior on the base class. And we're going to put in here self.transition. And so that's how the door opens. And we can add that to here, self.transition, and I've got to put an F there. And so that adds it to close. And then def transition self. Let's see. So the transition is going to say return by plus self.transition string. Why am I going to so much trouble here? Hopefully you'll be able to see when I get done. If self.transition string is not none, So that says if my transition string method returns anything other than none, I'll say the door opens by whatever the transition is. And if it is not none, or if it is none, then it'll just say the door opens. And so now I need to provide a transition string method. Return swinging on its hinges. No, I'm sorry. A generic door doesn't have a transition method. It doesn't have a way of opening. It just opens and closes. And so that should return none. So right now, whoops, I forgot to put string in here. Or not string, self. Okay. There we go. So I need a front door to provide a transition string. And this is the one that says return on its hinges. And so now when we call open, it will invoke this and it will call this method, but it calls it on the most basic class, or on the most specific class. So it won't call this method here, it'll call this method here because it's a front door. And so now we'll see the door closes by swinging on its hinges. I forgot to put a space before that. The door opens by swinging on its hinges. The door closes by swinging on its hinges. So if I wanted to make a car door, well, it swings on its hinges too, right? So is it a type of front door? Well, with what I'm doing here, that would work. But is a car door really a front door? No, it's similar to a front door in that they both swing onto their hinges. But other than that, they're very different, right? At least in our concept they are. So perhaps I need to make an intermediate class here. Swinging door, which is a door, and it's going to get this behavior, and so this one I can make a swinging door, and I can now make this one a swinging door. And I need a little more space there to get rid of the squiggly. And so now if it's a front door, opens by swinging on its hinges. And if it's a car door, it opens by swinging on its hinges. And if it's just a door, it just closes and opens. So what is something that a car door might do that a front door doesn't do? Well, let's see. When I open the door on my car, the dome light turns on, right? So I want to add a little more behavior to my car door. So when it opens, I'm going to call and then I'm going to print light and self.light. light equals on. And then when it closes, let's see, I really am going to copy a lot of this, aren't I? And I just have to replace on with off. Okay, and so now we can see that a car door opens by swinging on its hinges, and why didn't I notice that? Oh, I called open here. Should have called close. All right. That's a little better. Okay, let's see. So the door closes by swinging on its hinges and it turns off the light. Door opens by swinging on its hinges and turns on the light. Whereas the front door doesn't do anything with lights, just turns them off and on. So this is what what class inheritance does for you. I'm able to write a class door and define base behaviors, but then I can derive from that and get all the behaviors and properties of the base class, which makes writing each successive class easier. But you have to be careful when things look alike. Are they really the same, or are they just similar to each other? For example, maybe I could, this isn't a great example. Maybe I could say my front door latches. So then I would say def open self super dot open print door latches def close self super, and I forgot the parentheses there. I didn't talk about super, did I? Let's talk about that as soon as I get this written. Dot close print, and actually I need to unlatch the door before I can open it. So actually, let's call this, no, just leave it like that. So the door closes and latches when you're, oh, that's for open. When I close it, the door latches. Boy, I had that backwards. And I didn't set a instance variable there to be consistent. I should have, but I haven't done that. So what is super? Super says the next class that I'm derived from. And so that means that from front door, it's going to call swinging door.open, or close, since I pointed to close. Well, there is no close here, so it's going to go up the chain till it finds a close here, and it will invoke that. And so now, a front, let's see, what kind of door are we working with? It's a front door. So door latches, closes by swinging on its, oh, I got those backwards too. Because okay, let's try that again. Okay, the door closes by swinging on its hinges, the door latches. The door unlatches, door opens by swinging on its hinges, door closes by swinging on its hinges, the door latches. And so really, I should say I need to turn the knob. Turn the knob and door unlatches. And so that would be a difference between the front door and the car door. The car door also latches and unlatches. So I have a latching behavior. Let's see. So this is print. I don't know how your car door opens, but pull on handle and the door unlatches. Turns off light. And I don't know what print latches. Well, now if we look at this, we've got this behavior of latching, which is common between these two kinds of doors. Not all swinging doors latch. My refrigerator door, for example, swings, but it doesn't latch. So maybe I need to define a latching door, which is also a door. Notice it's not a swinging door, because there could be doors that don't swing. My sliding glass door might latch. So now we say def open self print door unlatches. Super.open def close self print door latches, and I should have done super.close there. And so now front door is both a swinging door and a latching door. And likewise a car door is both a swinging door and a latching door. And so now, what are we working with? We're working with a front door. Whoops. Object super has no attribute close. That's because I forgot to put the parentheses there, line 42. And I forgot them there as well. Let's see if it works this time. There we go. Okay. The door closes by swinging on its hinges. The door latches twice. So turn the knob, door unlatches, door opens by swinging on its hinges. Why is it door latches twice? Oh, because I still have that behavior here. So they shouldn't say latches. This is it's a front door. Why is front door latching twice? Okay, let's see what happens now. Okay, somehow I cleaned it up. Door closes by swinging on its hinges. Door latches. Now we're going to turn the knob. Door unlatches. Door swings opens by swinging on its hinges. So I've broken out into a lot of classes here. And what I've tried to do is illustrate how you can take common properties and combine them. So a front door is both a swinging door and a latching door. So when I call super, it looks at swinging door, say we're closing, has no close. So then it goes to the close here, the door closes. And then down when I want to open, oh, I'm sorry. So it did that for swinging door, then it does it again for latching door. It looks for close, door latches, and actually it makes sure that it doesn't call the base method twice. That's interesting. In other programming languages that can be an issue, but here it didn't call the door method twice. It only called it once. So that's good. So you can use classes to divide up behaviors and properties in ways that are very nice. You have encapsulated the data here. Self._open is only accessed through the open and close methods. And we could ask, we could say def is door open, for example. Return. And so now that gives me a modular way, or an encapsulated way, to query the state of the door. I don't look at this value directly. I just say print the door is open if, put if on the next line. So if door is open. So obviously I had a little problem with naming that. Else the door is closed. Close print. And so now, whoops, front door has no attribute. Oh, is door open. So I called it two different names. Let's go just with is open. All right. What's the problem there? / redundant between brackets. Oh, really? Are you sure? It says that will work. There it is. So the door is closed. And so we've encapsulated the data by writing methods that access it. We don't do anything directly to _open. We only use the methods of door to deal with it. But we can ask if any kind of door is open or closed, because it's a characteristic of all doors. So if I have a car door, the door is closed. If I have a front door, the door is closed. So this behavior up here, where I just change the type of the object, but then I can use the object the same way, that's called polymorphism, which means many shapes or many forms. So I get the correct behavior for door based on what type it is, which I don't have to keep track of. I just know that a door opens and closes. Encapsulation is this data is hidden inside of the object. I don't have to keep track of that. I can query the door and find out if it's open or closed. Inheritance is this whole issue of inheriting behaviors from a subclass or superclass. Sorry, I get those backwards all the time. But it should be obvious since the function is named super. And
how are you?
Trying to remember if there's anything else I was going to talk about on this. So, okay, a lot of work for a trivial example, but hopefully that gives you a little bit of a feel for how classes work. And I know, for example, here, this gets really complicated because I have to call the transition string, and the reason why I have transition is so it can do this logic. Return by, but if it's not none, otherwise just get an empty string. And then each subclass only has to provide a transition string. And so swinging door provides a transition string. Latching door doesn't. Front door, car door, they don't because it's already provided by swinging door. And so these classes, especially this one, is not meant to stand on its own. And really this one is not meant to stand on its own either. These are what used to be called mix-in classes. I don't know what they call them now. But they're just little behaviors that I want to add into certain kinds of doors. And so I'm able to add them independently. And that's right, I mentioned the refrigerator door. Not def. Class refrigerator door. It's a swinging door, but it's not a latching door, at least in the case of my refrigerator. And so there's nothing that But I also get a light turned off and on. So I could break out the light in a separate class also. And it would be another one of these little classes that are designed just to be mixed into other behaviors. And so right now it won't turn on and off a light if I use a refrigerator door. Door closes by swinging on its hinges, the door opens by swinging on its hinges, the door closes by swinging on its hinges, the door is closed. So refrigerator got all the behaviors of swinging door, but it didn't get the behavior of door that controls a light. So if I wanted to get that one, I'd have to create yet one more class. Controls light. And this doesn't inherit from anything. It's because it's not specific to a door. Could be a switch, I suppose. Although I'm having the methods open and close, so it is related to doors. In this case, super.open, and I forgot the parentheses again, super.open, and that is turns on light, self.light equals on. Then I've got to remember to pull out the light behavior here. Controls light. This is, super dot close self dot I've confused some issues here, haven't I? This is self.open, but then I need to say print turns on light, and this needs to say print turns off light. Okay, and so now this can inherit from controls light as well. And so I didn't have to write any behaviors for refrigerator door. It inherits all of its behaviors from other classes. So if I have a refrigerator door, invalid syntax. Oh dear, what did I do wrong? Line 70. I forgot to put the close paren right there. Okay, let's try that again. Okay. Oh, interesting. Oh. Okay, I should have had swinging. controls light, calls super.close. There is no super. So this should be a door. All right. Door closes by swinging its hinges, turns off light. Door opens by swinging it, turns on light. And so that's my refrigerator door. My car door does those things, but it also latches. And my front door doesn't control any lights, but I open it by turning the knob. So again, this idea of being able to inherit behaviors from other classes, so I don't have to write duplicate code. There's more things that I could do here, but I think this is more than enough to get you bored of the whole subject. So if you've watched this far, thanks for watching. I hope it was at least a little bit educational.